Good morning, students. Unit-5 Coordination Chemistry. In this session, I am going to teach Werner's theory. Werner's theory, right? So, Werner's theory. The Swiss chemist Albert Werner was the first one to propose the theory of coordination compounds. Theory of coordination compounds. So let us consider the different colored complex. To cobalt 3 chloride with ammonia. So with ammonia. So exists different properties are also. Okay. So first Albert Werner being the Swiss chemistry தான் coordination பத்திய தியரிய ப்ரொபோஸ் பண்றாரு. அவர் எடுத்துக்கிட்ட ஃபர்ஸ்ட் காம்பவுண்ட்ஸ் இதுதான். கோபால்ட் 3 குளோரைடு கூட அமோனியாவை சேர்த்து ரியாக்ட் பண்ணும்போது அவருக்கு டிஃபரண்ட் கலர்டு காம்ப்ளெக்ஸ் டிஃபரண்ட் ப்ராப்பர்ட்டிஸ் இருக்கக்கூடியது. ஸோ அது மூலமா தான் கோஆர்டினேஷன் தியரியே இன்ட்ரடியூஸ் ஆகுது, ரைட்? ஸோ COCl3 to gives CO NH3 6 Cl3, right? So COCl3 dot 6 NH3 okay. So 6 yellow in color, so yellow in color, right? So next the COCl3 plus 5NH3. So COCl3 dot 5NH3. The complex CO NH3 5Cl and Cl2. Okay, so purple in color. Purple color, right? So the next CO Cl3 4NH3, right? COCl3 4NH3 to give different complex, two different complex, right? So one is here CONH3 4 and Cl2 Cl. Say a trans complex. And another one is here CONH3 4 Cl2 and Cl. Say cis complex. Right? Trans and cis complex. Structure of trans and cis complex. Second metal atom cobalt. Okay. So NH3. So NH3 4 times and Cl2. So NH3 and NH3 and NH3 in opposite Cl and Cl. It's a trans complex. The same ligands present in diagonally opposite side is a trans. So trans in green in color. Right? And cis. The similar group presents in same side. Okay. So Cl and NH3 is a cis complex. Okay. So cis, the same group presents in same side. In trans, the similar group presents in opposite side. Okay, so the trans is green in color and cis violet in color. So all the complex are having different properties are also okay. Differentiate with the silver nitrate solutions. silver nitrate solution. Okay, so the silver nitrate, that complex dissolved in silver nitrate reacts with the silver nitrate solution to give 3 moles of AgCl precipitate. 3 moles of AgCl precipitate. In second complex gives 2 moles of AgCl, and third complex, okay, gives the third and fourth complex gives 1 mole of AgCl. Are you right? So AgNO3 solution kuda in the complex react பண்ணும்போது நமக்கு 3 moles AgCl form ஆகுது. So inner the square bracket does not dissolve in water. So counter ion only dissolve in water. So that complex dissociated with the gives CO NH3 6 times 3 plus and 3Cl minus. Okay, so the 3Cl minus ions react with the 3 Ag plus ions in silver nitrate solution, right? So to form 3 moles of AgCl. Okay, so that solution, that complex dissolve in water to give CONH3 2 plus and 2Cl minus ions. 2Cl minus ion. So 2 AgCl. The 2 moles of AgCl is precipitated in both the compounds. Both the compounds contain complex cation and only one counter ion, Cl minus ion. So 1 mole of AgCl is precipitated. Okay, so white precipitate is occurs, right? So to increase the number of ions, to increase the molar conductivity. Okay, so the molar conductivity value is higher in first complex, then second and third and fourth. Okay, so the order of molar conductivity, the first is more conductivity of electricity. Okay, so due to presence of 3 ions, so number of ions increases, the molar conductivity are also increases. So the first is more conductivity complex, the second and then 3 equal to 4, right? Okay, students. Okay, next. The postulates of coordination compounds. Okay. Werner கொள்கை, 5 more questions. The postulates of Werner's theory. Postulates of Werner's theory. Okay, first point, the most of the elements. Okay, the most of the elements exhibit two types of valence. Right? The postulates of Werner's theory, in first point, the most of the elements exhibit two types of valence. The name, one, primary valence, the second one is secondary valence. Okay, so two types of valence. The first one is primary valence and second one is secondary valence. Okay, so all elements satisfied by primary and secondary valence. Okay, so the each element satisfied by both the valence, right? The modern terminology, the primary valency is referred as oxidation state, and secondary valency is referred as coordination number. Coordination number. Right, so in modern terminology, the primary valency is referred as oxidation state and secondary valency is as referred as coordination number. And for example, CO NH3 6Cl3 Cl3. So the primary valency referred as oxidation state. The primary valency of central metal ion is so 3 minus 3 plus, so neutral Ligand. Okay, so the net charge 3. So already you know that how to calculate oxidation state. Okay, so net charge is equal to the charge on oxidation number of central metal ion is X and plus the number of ligand and charge of the ligand. Okay, so multiply with the charge on the ligand. The charge on the ligand is 0, neutral ligand. So the X is equal to plus 3. The oxidation state of central atom 3. Next, the coordination number. Already you know that coordination number in previous video. Okay, so coordination number is 6. The number of sigma bond between the central metal atom and ligands. Okay, so coordination number 6. Right? So in this complex, the primary valency is 3 and secondary valency is 6. Primary valency is 3 and secondary valency 6. Right? So second point. Second point, the primary valency of the central metal ion is positive. The primary valency of central metal ion is positive in most of the cases. In most of the cases, the primary valency of central metal ion is positive. In certain cases, 0. In certain cases, 0. So for example, CO NH3 4Cl2 Cl, right? So the minus plus. Okay, so the oxidation state of central metal ion is the charge plus 1 is equal to the oxidation state of central metal ion X, right? So plus the number of ligand 4 plus 2. The number of ligands, neutral ligand 4 into 0. 4 into 0 plus the negative ligands 2 into minus 1, right? So the plus 1 is equal to X minus 2. X minus 2. Therefore, X is equal to plus 3. Plus 3 in positive. The primary valency of central metal ion is positive in most of the cases. K4. Fe Cn6, right? So 4 plus in potassium. So 4 minus in charge on the complex. Okay, so each cyanide ion minus 6 minus. Total 6 minus. Okay, so 2 plus. So 2 plus 6 minus is equal to 4 minus. Okay, so the sum of the charge. The sum of the charge on the central atom, central metal ion and ligands are equal to net charge. Equal to net charge. So 2. You write? So the primary valency of the central metal ions in most of the cases is negative. In certain cases is 0. Certain cases 0. Right? 0. CO Ni CO 4 times. Okay. So the neutral complex, the net charge is 0. The oxidation number of central metal ion X, right, plus the number of ligands 4. In charge on the ligand, so neutral ligand, charge is 0. Okay, so X is equal to 0. And Fe, CO 5 times. Okay, so 0. X plus 5 into 0. So X is equal to 0. Okay students, so the primary valency of the central metal ion, most of the cases is positive, in certain cases is 0. The primary valency always satisfied by negative ions only. Always satisfied by negative ions only. So for example, in this complex CO, so in this complex, right? So the 6 minus ligand 6 minus, so the oxidation state is +2. Okay, so the primary valency satisfied by negative ions. So always the primary valency always satisfied by negative ions. Okay, so in this complex satisfied by 6Cn minus ions. 6Cn minus ions. So in this complex counter ion 1 negative ions and complex ion 2 negative ions. So satisfied by 3Cl minus ions. Satisfied by 3Cl minus ions. Right? So another one example, CO NH3 6 times Cl3. Right? So 3 minus 3 plus 0 plus 3 plus 3. The primary valency always satisfied by negative ions. So satisfied in this complex, satisfied by 3Cl minus ions only. You right? Okay. So that's second point. And third point. Third point, the secondary valency satisfied by negative ions and positive ions and neutral molecules are combination of all these. Right? The primary valency satisfy பண்ணக்கூடியது negative ions மட்டும்தான். Okay, but on secondary valency coordination number referred as coordination number, so satisfied by negative ions, positive ions, neutral ions or combination of all these. For example, CO NH3 6 Cl3, the coordination number 6. Okay, the secondary valency satisfied by 6 neutral ammonia molecules. 6 neutral. The charge is 0, so 6 neutral ammonia molecules. 6 neutral ammonia molecules. You right? So another one example. K4 FeCN6. Okay, the secondary valency satisfied by negative ligands. Okay, so secondary valency referred as coordination number. The coordination number 6 in this complex, right? So the 6 coordination number is satisfied by 6Cn minus ions. right? Okay, so satisfied by negative ions. Okay, so in this complex CO NH3 4 Cl2 Cl, the coordination number is 6 in this complex. Okay, the coordination number satisfied by 4 NH3 neutral. So 4 neutral molecules and 2 Cl minus ions. So 2 negative ions. Okay, so the combination of all these, right? So the secondary valency satisfied by negative ions, positive ions or neutral molecules. Okay, so our combination of all these, right? Next, fourth point. According to Werner's, so there are two spheres. According to Werner's, there are two spheres of attraction around a central metal atom. Around a central metal atom or ion in a complex. Right? So the fourth point, according to Werner's, there are two spheres of attraction around a central metal atom or ions in the complex, namely the inner sphere or coordination sphere. Inner sphere or coordination sphere. Okay, the second one is outer sphere. Outer sphere or ionization sphere. Right? See the drawing. The central metal atom, cobalt. The central metal atom, cobalt. Right? The inner sphere. Right? NH3, NH3. So the example compound CO, NH3 6 and Cl3. Right? So Werner's first at the complex compound. Okay, so adukana drawing na idu. So inner sphere. Okay, so inner sphere and outer sphere. Inner sphere and outer sphere. Okay. Sphere. Right? According to Werner's, there are two spheres. two spheres of attraction around a central metal atom or ions in the complex. In a complex, okay. So the namely inner sphere. The inner sphere is a inner sphere. The inner sphere are also known as coordination sphere. Coordination sphere, and the group presents in this sphere are firmly attached. The firmly attached to the central metal atom. Central metal atom. So right, the inner sphere or coordination sphere. The inner sphere are also known as coordination sphere, and the groups present in the inner sphere are firmly attached to the strong bond between the central metal ions and ligands. Right? The secondary valency satisfied by neutral molecules, negative ions or positive ions. So that ions or molecules are called ligands. Right? So the groups present in the inner sphere are firmly attached, the strong attached. Okay, so strong bond formed between the central metal ion and ligands, right? So the outer sphere are also known as ionization sphere. The groups present in this sphere is loosely bound. Okay, the inner sphere firmly attached. Okay, so the outer sphere group loosely bounded in the central metal atom or central metal ions, right? And hence can be separated into ions. Okay, so separated into ions upon the dissolving the complex in a suitable solvent. Okay, students. According to Werner's, so two spheres in around the central metal ions சுத்தி ரெண்டு ஸ்பியர் இருக்கு. ஒன்னு வந்து இன்னர் ஸ்பியர் ஆர் கோஆர்டினேஷன் ஸ்பியர். சோ இது பாத்தீங்க அப்படின்னா ஸ்ட்ராங்கா பவுண்ட் ஆயிருக்கும். ஏன் அப்படின்னா இது ஹைபிரிடைசேஷன்ல இன்வால்வ் ஆகக்கூடியது. சோ அதனால இது 6 கோஆர்டினேஷன் நம்பர் 6. சோ sp3d2. So 1 plus 3 4 plus 2 6. Okay, so sp3d coordination hybridization, sp3d2 hybridization இருக்கிறதுனால இது ஸ்ட்ராங்கா பாண்ட் ஆகும். So hybridized orbital is strong bond, form strong bond. So it's a non-hybridized orbital. So non-hybridized orbital, central metal atom. Okay, so it's the outer sphere or ionization sphere. Okay, so suitable solventல இத கொண்டு போய் dissolve பண்ணோம் அப்படினா இது non ionizable. Okay, so இது அப்படியே CO NH3 6 3 plus, but in outer sphere ionizable. They are suitable solvent. Okay பாப்பா. So students, so இதுல ரெண்டு ஸ்பியர் இருக்கு. ஒரு காம்ப்ளெக்ஸ்ல ரெண்டு ஸ்பியர் இருக்கு அப்படின்னு வெர்னர் சொல்றாரு. ஒன்னு இன்னர் ஸ்பியர், இன்னொன்னு அவுட்டர் ஸ்பியர் ஆர் கோஆர்டினேஷன் ஸ்பியர். So another one is a ionization sphere. So coordination sphere பாத்தீங்க அப்படின்னா சென்ட்ரல் மெட்டல் ஆட்டத்து கூட firmly attached, நல்ல strong bond ஃபார்ம் ஆகிறதுனால இது என்ன செய்யாது, வாட்டர்ல டிசால்வ் ஆகாது, சூட்டபிள் சால்வென்ட்ல டிசால்வ் ஆகாது. பட் அவுட்டர் ஸ்பியர், so ionizable sphere, அதனால சூட்டபிள் சால்வென்ட்ல டிசால்வ் ஆகும். ஏன் அப்படின்னா இது ஹைபிரிடைசேஷன்ல இன்வால்வ் ஆகாது. ஓகே, சோ லூஸ்லி பவுண்டா இருக்கிறதுனால ஈஸியா சால்வென்ட்ல dissolve ஆகும். ரைட்? சோ இது fourth point. and next point, fifth point. The fifth point is a primary valency. The primary valence is non-directional in nature. The primary valence is non-directional in nature. In secondary, the secondary valence is directional in nature. Directional in nature. The primary valence is satisfied by negative ions. So in this example for in this complex, right? So the primary valency 3Cl minus ions. 3Cl minus ions is non-directional in nature. Okay students, so this non-directional in nature, hybridization la involve agadu. So in the 3Cl minus நீங்க எந்த டைரக்ஷன்ல வேணாலும் போடு. இதுக்குன்னு பர்టిక్యులர் டைரக்ஷன் கிடையாது. நான் இப்ப இங்க ஒரு Cl இப்படி ஒன்னு போட்டுருக்கேன், இங்க ஒன்னு இங்க ஒன்னு போட்டுருக்கேன். இதே நீங்க என்ன செய்யலாம் அப்படினா இத எடுத்துட்டு இங்க ஒன்னு எந்த டைரக்ஷன்ல வேணாலும் அவுட்டர் கவுண்டர் அயான்ஸ் நீங்க எந்த டைரக்ஷன்ல வேணாலும் போட்டுக்கலாம். ஏன் அப்படினா நான் டைரக்ஷனல் இன் நேச்சர். பட் இன் செகண்டரி வேலன்சி, the secondary valency is directional in nature, right? So involved in hybridization with the central metal atom. Okay, so sp3d2 hybridization. So the ligands placed in octahedral place, right? So octahedral place. இப்போ நீங்க இந்த டிராயிங்ல இந்த NH3 ligands வந்து எந்த டைரக்ஷன்ல வேணாலும் போடலாம். டிராயிங் தப்பாயிரும். ஓகே, Cl மைனஸ் நீங்க எந்த டைரக்ஷன்ல வேணாலும், கவுண்டர் அயான்ஸ் எந்த டைரக்ஷன்ல வேணாலும் போடலாம். ligands பாத்தீங்க அப்படின்னா பர்టిక్యులர் டைரக்ஷன்ல தான் இருக்கும். ஓகேவா? சோ ஆக்டாஹெட்ரல் டைரக்ஷன் 6 அப்படிங்கறதுனால ஆக்டாஹெட்ரல் டைரக்ஷன். அப்போ the primary valence is non directional in nature and secondary valence is directional in nature, right? So the geometry or polyhedron of the complex is determined by the three-dimensional spatial arrangement of the ligand. Okay students, the geometry of the complex or polyhedron of the complex. Okay, so already you know in previous video, okay, the defined coordination polyhedron or geometry. Okay, so the geometry of the complex is determined by the three-dimensional spatial arrangement. The spatial arrangement of ligand atom with the central metal. Ligand with the central metal atom. Okay, so for example, the coordination number is 6. The coordination number 6. The hybridization is sp3d2 or d2sp3. 3 plus 1, 4 plus 2, 6. Okay, 2 plus 1, 3, 3 plus 3, 6. The coordination number 6. The hybridization is sp3d2 or d2sp3. In sp3d2, so weak field ligand. In d2sp3 hybridization, strong field ligand. Weak ligand and strong ligands. Okay, so how to identify weak field and strong field ligand? Okay, the donor atom carbon, nitrogen and phosphorus contain ligands. The donor atom carbon, nitrogen and phosphorus. Okay, so contain ligands are strong field ligands. Okay, so strong field ligands. In other ligands are weak field ligands. So other donor atom contain ligands are weak field ligands. Okay, so for example in strong field ligand, so carbonate is a neutral ligand. So NH3 amine, Cn minus, cyanido. Okay, so strong field. Weak field ligand does not contain Donor atom carbon, nitrogen, phosphorus. Fluorido, chlorido, right? So bromido, oxalato, donor atom oxygen, oxalato, ethylene diamine is a strong field ligand. So donor atom nitrogen. Ethylene diamine En is a strong field ligand. Donor atom nitrogen. You right? So in weak field ligand, hybridization sp3d2 and strong field ligand hybridization d2sp3, the coordination number is 6, the geometry octahedral. The geometry octahedral, right? The coordination number 4. In coordination number 4, so two hybridization is possible. One is a sp3 hybridization, another one is dsp hybridization, dsp2 hybridization. So sp3, another one is a dsp2. So 3 plus 1 4. So 1 2, 2 plus 2 4. 4 coordination. In sp3 hybridization, the ligand is weak field ligand. Weak field ligand in sp3 hybridization. Example, nickel, Cl4 2 minus. So Cl minus is a weak field ligand. The hybridization is sp3. Okay, so the strong field ligand presence in strong field ligand presence in the complex. Okay, so the hybridization is dsp2. So for example, NiCl4 2 minus. So cyanido is a strong field ligand, right? So in sp3 hybridization, the geometry tetrahedral geometry. Geometry is tetrahedral geometry. In strong field ligand, the geometry is square planar. Square planar. Okay, so the geometry of the complex is determined by the three-dimensional spatial arrangement of the ligand in the complex. Right? So tetrahedral say, so nickel, Cl minus, Cl minus, Cl minus, Cl minus, Cl minus. Tetrahedrals. In this complex, nickel, Cn minus, Cn minus, Cn minus, Cn minus. Square planar geometry. Square planar geometry. Okay, so this is octahedral. This geometry is octahedral geometry. Coordination number 6. So octahedral geometry. Okay, so the following table illustrates the postulates of Werner's theory. Postulates of Werner's theory, right, students? Okay, so CO NH3 6 Cl3. Okay, so next CO NH3 5 Cl2 CO NH3 4 Cl2 Cl and CO NH3 4 Cl2 Cl. Okay, so yellow color complex, purple color complex, the trans green color complex. Okay, so cis violet color complex. Okay, the coordination number 6. Coordination number 6. The inner sphere or coordination sphere satisfied by secondary valency. So 6NH3. Okay, the secondary valency is non-ionizable valency. So non-ionizable valency. 6NH3. Okay, so 5NH3 and 1 Cl minus. in this complex. So both the complex 4NH3 and 2Cl minus is a inner sphere groups. Inner sphere groups. Okay, so it's a strong, firmly attached to the central metal atom, right? The secondary valency of the complex are 6. Okay, the secondary valency of the complex is 5 and secondary valency of the complex is 4. Satisfy the referred as coordination number, right? Okay, so the next, the counter ions are ionizable. So it is a non-ionizable. Next, ionizable counter ions. So 3Cl minus. Okay, so 2Cl minus. So both are 1Cl minus. 1Cl minus. Are you right? So presence in outer sphere, ionization spheres. So loosely bounded with the central metal atom. Loosely bounded with the central metal atom. Okay, the number of moles. The complex reacts with the silver nitrate solution to give the how many number of silver chloride precipitate. Okay, so in this complex, counter ion 3Cl minus ion. So 3AgCl. 3 moles of AgCl precipitate is formed. In this complex, 2AgCl. So both the complex. So 1 AgCl is formed. Do you right? Okay. Students, the next one is the limitation of Werner's theory. The next one is the limitation of the limitations of Werner's theory. The Werner's theory was able to explain a number of properties. The Werner's theory was able to explain a number of properties. So, but does not explain color and magnetic properties. Color and magnetic properties. Color and magnetic properties, right? So Werner's theory உடைய postulates-ல பார்த்தோம். நம்ம Werner's theory மூலமா நிறைய properties வந்து தெரிஞ்சுக்கிறோம். பட் ஆனா அந்த Werner's theory-னால கலரையோ magnetic properties-யோ explain பண்ண முடியல. So already you know that the complex compounds having colored. So CO NH36Cl3 yellow. So yellow color. So CO NH3 5Cl2 purple அப்படின்னு சொல்லி நம்ம ஏற்கனவே பார்த்திருக்கோம். So இந்த கலர்லாம் ஏன் ஃபார்ம் ஆகுது அப்படின்னு சொல்லி Werner's theory-ல எந்த எக்ஸ்பிளனேஷனும் கிடையாது. Okay, so why the complex compounds form color அப்படிங்கிறதுக்கு எந்த எக்ஸ்பிளனேஷனும் இந்த Werner's theory-ல இல்ல. So அடுத்து magnetic properties. So complex compound magnet-னால attract ஆகுமா அல்லது repel ஆகுமா அப்படிங்கறத பத்தி எதுவுமே எக்ஸ்பிளைன் பண்ணல. So paramagnetic and diamagnetic, ferromagnetic, antiferromagnetic. Okay, so நிறைய magnetic properties இருக்கு. அதுல paramagnetic அப்படின்னா unpaired electron. So unpaired electron இருந்தா paramagnetic-ஆ இருக்கும். So எல்லா எலக்ட்ரானுமே பேரப்பா இருந்துச்சு அப்படின்னா, so எல்லாமே பேர்டா இருந்துச்சு அப்படின்னா அது diamagnetic. Okay, so அத பத்தி எந்த எக்ஸ்பிளனேஷனும் இதுல இல்ல. So limitation of Werner's theory இது ரெண்டும் தான். So does not explain color and magnetic properties. So அதனால தான் அடுத்த தியரி valence bond theory introduce ஆகும். ஓகேவா? Thank you students. We'll meet next class.